This is another example of a direct proof, and rather than looking at division, it's better to look at it as a multiplication, especially as there's a bit of a string here, A to B, B to C, and then we connect A to C. So what we'll start off with is we will say, okay, if B is right now, when this is A divides B, what it means is sort of A divides B. We often say evenly or exactly, as in A, I suppose, is a factor of B. A can divide B such that you get a whole number answer. So in this case, if we turn it around and think of it as a multiplication, we can say that there's a constant, let's call it K, that I multiplied by A such that I get B. Okay, and all I need to say is that K is some natural number. Okay, and I suppose you could also say it's an integer. I mean, we don't have to worry too much about the minutiae of that one. We could put an integer value in there instead. I'm sure someone would argue with me about that one, but you wouldn't get marked down for it. Key idea is K is just a whole number. Okay, because that's the answer you get when you divide B by A. Now, then we have a second statement, which is B divides C, i.e., okay, C, if you divide it by B, you get a constant value. So, okay, I have to have a different letter now. Let's call it P, let's say. And B is dividing C, and you would get the answer P. And again, P is just some integer value, some whole number value. Now, okay, if C is equal to P multiplied by B, well, then C is equal to P multiplied by, well, what B represents, which is Ka. Now I can write that actually with a K multiplier out the front. Okay, so whatever A is, if we multiply by P and K as a multiplier, we get C. Therefore, we can see here that using the same logic as we start off with, okay, we can say that A divides C, okay, in the same terminology.